All right, welcome to Chapter 9, Section 3, called Comparing Sets of Data. This is for Math 8. So a couple things you will see on your screen here. The first thing you should see is a due date. I don't see it on my teacher preview here, but you'll see it on your student screen. The second thing is the number of attempts. So you always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many questions are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. Partial credit is enabled, meaning if you answer 1 of 5 questions correctly, you get credit for 1 question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click the start button here, down in the bottom right corner, I will see a submit assignment button. And I have to click that button for 2 huge reasons. The first one is just like that said, you can't work on anything else till you click that button. That's by finish your assignment, it means click submit assignment. And what Alex will do is it will lock every other assignment. If you just leave this screen by clicking the X, or if you close your computer, it's going to assume you want to leave this attempt open, and it's going to lock all of your other assignments until you come back to this one. Remember, you have unlimited assignments, or unlimited attempts. You don't need to leave this attempt open. And if you've worked on some of your assignments and you have a little green check mark, you won't have to do those ones again. It's going to start you back up wherever you left off. So that's a big one, so it doesn't lock your assignments. The second big reason to click Submit Assignment down here in the bottom right corner is it affects the grade book once you click that button. So your teacher can actually see what you've been working on. Until you click Submit Assignment, your teacher has absolutely no clue what you've been working on. Basically, it's just paused, your entire account. So, good idea. Always, always, always click that button. On the side here, we have Explanation, Example, and Message Center. Explanation tells you you're going to lose your current question attempt because it's going to give you the answer to this question. It's not going to give you the answers and let you come type them in. Sorry, not how this works. Example shows you an example of something very similar to what we're looking at here. So in this case, we're looking at a kind of a two-way table, meaning that there's data along the top, data along the side, and they match up. And we have to take the information that they're giving us and fill in the chart here. So we're just going to go through, and you can see how they're highlighting and saying, fiction and boys. Okay, well, they told us that it was 5 based on some information that they gave us up top here. So we can fill this chart in. It's just a way of organizing our data. We can click on this for another example if we'd like. We can also message our teacher directly from the screen. It attaches a picture as well, so your teacher knows exactly where to come help you. Okay, so let's go ahead and take a look at this. So it says, each of 66 students in grade 1 through 3 was asked, can you swim? Here are the results. So first, can you swim? That's kind of the first category we have here. Cannot swim, can swim. That's really the only 2 categories they're allowing. Either you can or you can't. So 8 students in first grade, 11 students in second grade, and 6 students in third grade cannot swim. So we're going to go to cannot swim, and we're going to go down the list here. So in first grade, 8 said they cannot swim, 11 second graders said they cannot swim, and 6 third graders said they cannot swim. Then we'll go to the second statement here. It said 10 students in first grade, 14 students in second grade, and 17 students in third grade said they can swim. So we're going to go to the can swim column here, and we're going to go straight down. Can swim for first grade was 10. Can swim for second grade, that was 14. And the last one here, can swim for third grade, was 17. So I can see can swim and third grade, so that's why the 17 goes here. It's like cross-reference. Cannot swim and third grade goes down here. So I'm cross-referencing those column to the row. So it's just a way of organizing your data in a chart where there's 2 pieces of data there. So each of 52 moviegoers was asked, what is your favorite movie type? So this is our first category, movie type. So on this one, either comedy or animated is the choice here. So, and it doesn't matter. I could put comedy here and animated here. That's not going to make a difference. Because it's 2 choices and 2 choices, I could also decide I want comedy and animated on the side, and I want men and women on the top. Alex will actually accept quite a few different versions of this same chart. So I could also do men and then women. Or this could be animated and then comedy. As long as I have one of each, because they asked men and women, and what type of movie, I'm okay with this chart. So we'll go ahead and leave it this way. Since I've typed it up this way, it says 12 women and 11 men choose comedy. So I have comedy, and it says 12 women, and then I'm going to go across to 11 men. And then 15 women and 14 men choose animated. So animated, 15 women and 14 men. Ta-da! All right, check. So again, there was at least, 4 different ways that I could have done this, because I can swap these, and then I can also switch comedy and animated to the top, men and women to the bottom, and then I could also swap those. So 4 different ways I could fill this chart in at least. Okay, so in a survey, 150 shoppers were asked whether they have access to a computer at home and if they have a personal email account. Their responses are summarized in the following table. So email account, no email account. Computer access at home, no computer access at home. So this is saying people who had computer access at home, there's 44 of them that had email accounts and 19 that did not. No computer access at home, only 13 had accounts and 74 did not. That makes a little more sense. If you don't have computer access at home, it's much less likely that you probably have a personal email account. So it kind of just depends. Although now I would think that it would be more like a smartphone instead of just a computer. All right. So what percentage of the shoppers do not have an email account? So now we're looking at percentage. So what we want to do is look at total over the piece, one piece we're looking at. So if it says what percentage of the shoppers, well, that's all of them. How many shoppers did we ask? I know it's only going to let me highlight shoppers here, but I'm looking for that 150 before. So we asked 150, how many of those shoppers do not have an email account? So I'm going to go to no email. I don't want just 19 or 74. I want to know all together how many do not have an email account. So I'm going to add these two together, and I know it's kind of upside down, but addition is okay with that. So I have 13, 7, 8, 9. So 93 out of the 150. So 93 out of 150. We do need to go over to our calculator here. 93 divided by 150. So this tells us that it's 0.62. They want a percentage, so we either need to multiply by 100, because that would do the trick for us to move the decimal. So it's 62. Or I can just take this decimal and go 1, 2, and so it's 62%. Either way, gives me 62, if you know how to move the decimal like that. So 62% of the people asked, these shoppers, did not have an email account. All right, what percentage of shoppers have computer access at home? So again, we have all the shoppers. What percentage of the shoppers have computer access? So computer access is across here. So it's 44 and 19. So 44 and 19 together, I have 13 again, 4, 5, 6. So 63 out of 150. So let's go 63 divided by 150 equals 0.42. So again, I can multiply by 100 or just go 1, 2. So it's 42%. I would think this would be pretty low. I think most people now have computer access at home. It's pretty common at this point, but I guess it depends on where they were asking shoppers. All right, so a group of 200 college students who took math last term were interviewed. They were asked whether they passed their math course and whether they lived on campus. Their responses are summarized as follows. So we have passed or failed. That's our first category. Did they pass math? The second category was, did they live on campus? Live on campus, live off campus. So we have 2 categories, and we're kind of comparing these. So we're saying, if you lived on campus, was it more likely that you passed math or you failed math? In this case, it looks like it's more likely that they passed math if they lived on campus. If they lived off campus, is it more likely that they passed or failed? So it kind of looks like living off campus means that it was more likely to fail at the 73 over 43. So again, just kind of depends on what we're comparing there, but we're just looking at different pieces. So what percentage of students passed math? So we want to say, of all the students that we interviewed, what percentage passed math? So I want this total here. So that would be 6 and 10, so 106. Sorry, I know I added that a little funny. I should add it straight down. So I want to do this again. So I have 106 divided by 200. So it's 53. And I'm just going to, I'll do the 0.53 and then it's boop, boop. So it's really 53%. All right. So now let's go to part B, and I'll type these all in just a minute. So what percentage of students live on campus? So all students and live on campus, So we're going 63 plus 21. So that's 3 plus 1 is 4. 6 plus 2 is 8. So we're going to go 84 divided by 200. And that gives us 42. 0.42. Boop, boop. So we get 42%. All right. What percent of students who lived on campus passed math? Now we're getting a little bit more picky. I don't want to know all of the students. I want to know the students who lived on campus. So this 84 students here, we just added those 84 up. Now I'm limiting it. I'm not talking about all 200. I'm only talking about the 84 who lived on campus and what percentage of them passed math. So that was 63%, or 63 out of 84, sorry, not percent. We need to divide for the percentage. So 63 divided by 84 gives us 0.75, which we're going to go boop, boop, and we're going to have 75%. All right, so let's go ahead and type these guys in. So I had 53, 42, and 75. All right, so it says, is there evidence that shows students who lived on campus tend to pass math more often than average? So if we look at the percentage that it just gave us, average is kind of the, not necessarily in the middle, but we want to see that it's kind of a middle variable that we can look, not variable, but a middle data point that we can look at. So let's read these really quick. So no, because the percentage found in part C is about the same as the percentage found in part A. So those are pretty far off. So I think if the percentage of students that pass math is 53 and the percentage of students that live on campus is 42, and 75% of those students that have passed math that live on campus. So that's not the same. That's definitely higher. No, because the percentage found in part C is about the same as the percent found in part B. Nope, definitely not the same. Those are very different. Yes, because the percentage found in part C is much greater than the percent found in part A. Or yes, because the percentage found in part C is much greater than the percent found in part B. So it's much greater than both. What we have to do is make a decision. Which one actually tells us the answer, or like which directs us to the point of the answer we're trying to make. So is there evidence that students who lived on campus, so these students here, tend to pass math more often? So if we're asking the average of students who pass math, we want to compare it to the percentage of students that pass math here. So 53% of students in general pass math. But if we live on campus, that percentage goes up to 75% pass math. So I'm pretty darn sure what we're going to do is compare that to part A instead of part B. So let's check that, make sure that I'm not losing my mind here. Yay! So they're giving us two things to compare it to, which we're talking about students who live on campus, and that's this guy. But what we want to know is, do they pass math more often? That's really the data point we're pointing at. So here's the students that pass math on average. Here's the increase, or the different percentage, once we live on campus specifically. So it's just kind of paying attention to the data points there. What do we see? All right, so a sample of 309 people is surveyed. The people are classified according to political affiliation, so Democrat, Republican, or Independent. They are also classified according to opinion on a bill, in favor of, opposed to, or different to. So the results are given in a contingency table below. So we have, here's the favor of the bill, so in favor of, opposed, and different to. Democrat, Republican, or Independent are down along the side. So for Democrats, 27 were, of the 309, 27 were in favor, 33 were opposed, 37 were indifferent too. And remember, not all 109 are Democrat. 309, that's everybody all added together. So there's not 309 Democrats. There's 309 total people surveyed. All right, so what is the relative frequency of respondents who are Democrat? So we need to make sure that we pay attention because this is a different type of calculation here. So contingency tables give information about two categorical variables. So we've been dealing with that already. So along the top, along the side. In this problem, the two variables are voter registration. So they kind of change this voter registration status. So they're registered or not registered. And preferred source of information, television, newspaper, radio, or internet sites. Each of the adults in the sample is placed into one category for each of the variables, and the resulting frequencies are shown. So frequency means how many times does it show up? How many times did somebody say that I'm registered and my preferred information comes from the TV? That's all it is. How many times did this happen? That's what a frequency means. So the adults who prefer to obtain their information through radio are represented in the third column because it's asking us what is the relative frequency of adults in the sample who prefer to obtain their information through radio. So we're specifically looking at the radio column. Of the 231 adults in the sample, 26 plus 36, so you can see that, which is 62, prefer to obtain their information through the radio. So they added them together to get the total who prefer this, and they're dividing. So this is actually, for some reason, I was thinking relative frequency would be slightly different, but they're just using that idea relative to what they're asking. That's the idea. So they're using different wording, but it's really the same thing we've been doing. So what is the relative frequency of respondents who are Democrat? So I want to know how many are Democrat. So 27, I'm going to go ahead and add this over here. 27 plus, go back, 33 plus 37. So of the respondents, of the people who responded, 97 of them were Democrat. Relative frequency means I want to divide by the 309. So then I can see, what's the frequency that they're showing up. And I want to make sure, did they have that typed in as a decimal like that? They did. So it's a decimal here. So they want us to round it, it's a percentage. They're just not having us write it as a percentage. So it says round your answer to the nearest 2 decimal places. So I want to go down to 2 decimal places here. I just want to make sure that this does not round me up. So because it's 4 or smaller, it's just going to drop away like that. So I have 0.31, which I can think of, that's 31%. So 31% of people who responded to this survey would be Democrat. That's what I can kind of estimate here. All right, so that was section 3. I will see you in section 4.